Okay, so in this video we are going to learn how to one, calculate the area of a triangle, two, how to do this in the easiest way for computers to calculate the area of a triangle, and three, we're going to look at a little bit of, I don't know, pseudocode, C++ code, whatever I decide to write up, on an algorithm that will actually do this for us. Basically, I'm going to be doing a series of videos that are going to lead up to some polygon triangulation algorithms. And the first thing we need to know is how to calculate the area of a polygon, specifically a triangle. So let's kind of go back to middle school here and look at the old school formula of how to calculate the area of a triangle. I think every fourth or fifth grader knows that the area of a triangle is equal to 1 over 2 or 1/2 times the base times, whoops, that should be an h for height. Ooh, that was not cool. Let's undo that. And give me just a second here. I really royally screwed up. There we go. Okay. Let's go back to red. And that was base times height. Okay. So everybody knows that. The problem with this particular formula, this formula looks really, really good for nice, perfect triangles that are drawn where the base is 100% oriented with the x-axis, and we don't have to actually calculate the height of an arbitrary orientation. However, if our triangle is arbitrarily oriented, say like oh, that was just wrong. There we go. Like that, obviously the base is going to be a little bit hard to calculate. So what we can do is, if we know the angle here, theta, and we know two of the sides, A and B, then we can use some trigonometry and we can say that the area of the triangle is actually equal to 1/2 A B sine of theta. If you didn't take trigonometry, this is basically using, well, basically it's a cross product rule, but we're going to be using that to determine the area of our triangle. This is great. That's cool, but if you've ever done any computer programming, you'll know that dealing with sine and angles, that right there actually requires you to calculate angles, which is not really something I want to do. I don't know about you. So we're going to take this another step forward, and we're going to go into some linear algebra, and remember that the cross product of two vectors is equal to the 2 times the area of the triangle. So let me step back here and let's draw that out and see what it looks like. So if we have a triangle, I'm drawing another one. This one we're going to orient properly. So we have this triangle, and we want to know its area. Well, if we take the cross product of this vector from this point here to here, and this vector here to here, what it'll actually give us is the area of this this parallelogram. So what we can do is we can say, oops, hold on one second. Let's change that color. I changed the color, but let's get back on the screen. We can say that the area of the triangle is actually equal to 1/2 times the absolute value of A cross B. And these are vectors. So, if you haven't taken linear algebra, how do we do this? Well, for a nice simple 2D triangle, which is what we're dealing with for the brute force triangulation algorithm later on, this is actually not that hard. So let's change the color so we can keep track of what we're doing here. Let's go to maybe a nice blue. And did I just zoom in by accident? think I did. Oops. Wrong way. Wrong way. Oop, too far. Sorry, plane. Okay. So, let's see how I want to do this. Okay, let's go right into it. Let's just draw a triangle that we want to know the area of. There it is. And we're going to do this all in variables. So we'll say this vertex here is A. This vertex here at the base is B. And this vertex up here is C. And what we're going to do is we're going to take the cross product, 1/2 cross product. This is vector 1, vector 2. We're going to take the cross product of vector 1 to vector 2. Okay? And we'll call this polygon 0. Okay. So how do we take the cross products of it, you ask? Well, first we have to actually figure out our vectors. And we figure out the vectors by basically just doing a quick little subtraction on the x and y axes. So we'll say that vector 2 is equal to bx minus ax, by minus ay, and vector 1 is equal to, and actually I really should have, I'm sorry, I'm going to go back here a little bit. This should be vector 1 and this should be vector 2. Just because I want to keep them in the nice ordering that I had on my paper here. So, vector 1, vector 2, 1 and 2. There we go. Cool. And this one's the same thing, just put for C. So it'll be cx minus ax, and then cy minus ay. And there's our vectors. Nice and simple. It's basically just subtraction from the endpoint to the beginning, endpoint to beginning. And now we want to take the cross product of that. And the cross product in linear algebra would basically be the determinant. So we'll come down here and we'll do a nice little determinant. So let's see here how we want to do this. Let's do it over here a little bit maybe. There we go. So it'll be, oops, not C. That should be a B. And again, I do apologize for my atrocious handwriting. Cx minus ax, cy minus ay, and basically we take the determinant of that. If you remember how to determinants, it's basically this times this minus this times this. Let's change the color here to spruce it up a bit, maybe a nice green. Oops. Nice green. So we'll take this and this, so this times this. Okay, so that's bx minus ax cy ay minus, and then we'll do this in a different color too. So this and this. So that'll be by ay cx ax. Okay, and then with that we basically just can FOIL that out. Let's continue using yellow. I like yellow. Don't ask me why. So what we'll do is, you have to give me a second here. I'm kind of running on half power today. So bx cy minus bx ay minus ax cy plus ax ay, by cx, but that's minus, plus BYAX plus AX, oops, sorry, that should be AY. So it was plus AYCX, and then plus minus AYAX. Now we have another AYAX, that's plus, that's minus, these cancel out. So let's mark those off before we go down into the next round. Whoops. That was supposed to be red, so we don't lose track of it. So there we go, that goes away, and that goes away. So we're left with this now nice, big expanded polynomial here. How about something in a nice bluish color? Purple. I like purple. Okay. So now let's go back here a little bit before I write this out. Remember, this was 1/2 times the cross product of vector 1, vector 2. Well, we forgot all those halves. We need to add them back in. There should have been a 1/2 here, and then some sort of 1/2 and this one too, and then here. But we'll write it down here just because I was being clever and I purposely left it out to not get people distracted. So we'll do 1/2 bxcy minus bxay minus axcy minus bycx plus byAX plus AYCX. And there's our area. Now, I know it looks really complicated, especially compared to this half over BH, but remember that doesn't necessarily work in a nice, easy, clean way when our triangle is oriented in some, very odd fashion. What happens if my triangle started here and went, to there, and yeah. So, okay, that's more of a right triangle. Let's try something else. Let's try that one, and then maybe that one. And that one. There we go. Actually, that's a right triangle too. Why can I not draw anything but right triangles? That and that. Okay, I'm giving up now. Hold up. One more time. That. There we go. Ha ha. I have to go out. Why am I so bad at drawing? Oh, right. I'm a computer scientist. I'm not an artist. There we go. There we go, not a right triangle. Bad. Good. So that one right there, it would be perfect for this type of situation because our base, let's say our base was that one, that's really off, angle. That's not the normal orientation you see when you're in 4th grade. So using this solution way down here, we get the area, we get 2 times the area, that's why we divide in half, of any triangle we throw at it. So this is really cool, and we're going to use this in probably another video very soon on calculating what we call left of values. Is 1 point left of 2 other points. And we use that for checking for collinearity, yeah. Checking if 3 points are collinear. And we'll also use it for discovering, we'll use all of this for discovering if there's a diagonal between 2 vertices in a polygon. And we'll do some other interesting little things with it. So this is kind of the base of our brute force triangulation algorithm we're going to start off with. So what we're going to do now, let's see, I have some code here. Wonder if I can just copy and paste this into the photo editing program here. So what we're going to do is we're going to paint over all of this in a nice black color. Whoops, hello, that was not supposed to come up. That's a very nice color, not what I'm looking for though. And we're going to come over here and... Ooh, isn't that pretty and black and not what I was looking for at all. Let's try it again in a different color. Hey, there we go. So you can see here area of a triangle uses cross product. We have a float, area 2. Now I say 2 because it is calculating twice the area. We divide by half, but it's actually area 2 for the fact that it's 2D. We're doing this in 2D, not 3D. Obviously 3D would be volume, duh. So, area 2, and we have, this is in C++, so we're bringing in vertex A, vertex B, and vertex C. Each vertex contains X, Y, and Z coordinates. And then we basically are returning that wonderful, big, monstrous thing we had a few minutes ago. Whoa, hello. Hold up 1 second here. Let's see. It's kind of... Excuse me for doing this while attempting to... Let's bring that... There we go. Okay. So you can see here we have BX... Grab my painter here, and maybe something in green. Green. Can I draw, please? Anything? Here we go. Okay, so we have BXCY, BXAY, AXCY, BYCX, BYCX. Oops, those are backwards. Ignore that part. Sorry. Sue me for screwing up there. Those are backwards. When I wrote it into my programming language, I got these backwards. So that should be AYCX and BYAX. And then, of course, let's not forget our divide by 2, which basically accounts for taking out the other half of our parallelogram. And that's pretty much it. That right there will calculate the area of a triangle using a little bit of linear algebra, a little bit of trigonometry, and we show you a nice little C++ algorithm or function that will do this for you that you can type in and run and do whatever you need to. So with that, goodbye. See you.